D&D's environmental education coordinator. And so we usually just start out with like acknowledging that we're on traditional and unceded territory of the Duwamish people. It's also the traditional lands of the Muckleshoot and the Suquamish tribes, but the Duwamish aren't recognized. And so it's like particularly significant that we all reside here with, you know, there are tribal members in the city that still don't have any treaty rights. Yeah, so I'm going to talk about DNDA. We are a community development nonprofit out of West Seattle. We do that through art, access to art programs and like public art. We do a lot of restoration and environmental education through nature. And then we also run several low-income housing properties for the residents of Delridge. Yeah, and so through our nature program, we do a lot of restoration, which is sort of like what like spearheaded this idea for this workshop. And part of our restoration program is like we bought a wetland, like an old wetland site that was a substation, and we started restoring it. And that's where we do community education through the local STEM school and through these workshops. So that's why we're here. So wetland workshop on restoration practices in a changing climate. Yeah, and so I think partly the like inspiration behind this workshop is that we use reference ecosystems and like target ecosystems for our restoration practices, which is where we just try to get them as close to the plant communities that were here before colonialization or just like mass settlement. And so a personal question has, and okay, sorry, back up a little bit. There is often just a ton of maintenance that's required with doing that to keep the invasive species out, to keep like these native species healthy and intact. And so my personal question is, is it still the most effective way to look at these target and reference ecosystems? And is the way that we're doing it, can we do it in a way that is a little bit more or like less intensive for the people who are taking on these restoration projects? Yeah, so we have Matt Distler from Oxbow Farms and Conservation Center, and James Lee from the School of Marine and Environmental Affairs. And so just to give everyone a quick agenda, we'll start with Matt, and he has his 45-minute presentation. And then we'll have a little section for questions, and then we'll pass it on to James Lee, and then we will end it with a larger Q&A session at the end. And I use she, her, or they, or them pronouns if anyone is curious. Okay, so with that, Matt, do you want to take it away? You're muted.
Yes. Sorry, just make sure I can share my screen here.
Perfect.
And then I often try and fit too much into a presentation, so I apologize if this ends up that way. One thing I'd like to ask is whether you guys can see the nice full screen of my presentation here, or whether you're seeing all my notes as well.
Looks like it's just...
Looks good.
All right, great. Thanks. Yeah, so I'm Matt from Oxbow Farm Conservation Center, and I'm the conservation program manager at Oxbow, which is just sort of one wing of what we do. Oxbow is focused on sort of the benefits, both societal and health-wise and ecological, that come from using a regenerative agriculture approach and sort of ecologically sensitive approach to land use. So tying together agriculture and the restoration of our ecological communities, of our landscape, for better human health and ecological health and better society. And so I'll be, of course, talking about that intersection between restoration ecology or ecological restoration. I'll use both of those terms and I'll explain them a little bit more in a moment, and climate change. And I do want to say that I'm not a climate scientist. I'm an ecologist, and so I'll be hearkening to a lot of climate science, but I'm definitely not an expert in that, and I can point everyone toward a lot of the work done by the Climate Impacts Group at University of Washington and other groups for more information on that, but I'll also be happy to try and answer any questions that come up on that. But really, I come from this as someone who's been planting plants along streams and trying to improve the health of our riparian streamside ecosystems for a number of years, and looking at forest change and just wondering myself how to best approach that work in an era of climate change. And I've titled my presentation bringing back a new landscape, which I think hopefully captures a little bit of the paradox, I think, of what Bree was alluding to, what we as restoration practitioners kind of face, which is we're trying to bring back something, the definition that's often used for ecological restoration. What I and several of us do is assisting the recovery of an ecosystem that's been damaged or degraded or destroyed. So, and if you look at both the title of the work, ecological restoration, and that definition, it all talks about going back to something. But we have this problem now that we know we can't really go back anymore to historical conditions in a lot of our forests and our aquatic systems because of all of this change. So we as a profession, and probably all of us as a society, need to think about what that means. And this is some of what I'll be talking about in this. Another way of looking at it, I feel like Gary Larson always brings a good new perspective on this, is we're trying to figure out how to succeed in the face of the unknown, unlike this poor troglodyte on the right here who has gotten an F in history, which hasn't yet happened. We want to try and get an A in what is yet to happen. So very quickly, I'm just going to remind us of what the science says is coming to us, which is maybe the depressing part of the presentation, but happily, I think ecological restoration is a hopeful art, and we can move to a more hopeful side of this after that. Science tells us that we've already experienced quite a bit of warming, over 1 degree Fahrenheit, since the end of the 19th century, and that we can look to another 4 to almost 6 degrees Fahrenheit warming by the middle of this century. It's a little hard to imagine what that past warming means or what that future warming will feel like. But if you look at this climate hardiness map that we're, as gardeners, may be familiar with on the right-hand corner, some of us, whether we're environmental professionals or not, may have noticed that we were bumped up a whole half a zone when that system was reassessed in 2012. And so that's maybe a little more visceral. There's now a whole list of things you can plant in your garden according to our hardiness zones that we could not before. And that there is more change like that coming. Other things that climate science tells us is that while mean annual precipitation, the amount of rain over the year, is maybe not going to change, what is going to probably change is that our already pretty dry summers here are going to get drier, and our wet winters are likely to get even wetter with heavier downpours as part of them, and all the hydrological implications of that. Along with those changes in precipitation, there's going to be other changes to hydrology that come from our snowpack and the mountains melting earlier, as much as a reduction of up to 50% or more of our spring snowpack toward the end of this century is really going to change a lot of how our rivers flow, like the peak flow times. It decreases, again, possibly up to 50% in our summer low flows in our rivers, if what the more dire projections that the global circulation models come true. And then conversely, greater flooding events in the winters. And of course, sea level rise is another concern for communities along the coast and for people trying to maintain the health of coastal communities. So that's this sort of somewhat scary snapshot of what we're looking at as far as the changes in our environment in the coming century. And again, it's sort of hard to sometimes imagine what those things will feel like or really mean on the landscape. And there was a little bit of work done by Miriam Marlier in 2017 that looked at the year 2015. If some of you remember, an incredibly dry summer, a warm, dry spring with much reduced snowpack, leading to over 1 million acres of burning in Washington, an all-time record that summer. And what we saw in actually the following spring, a lot of conifers, like in the sort of middle lower inset picture there, dying off in our planting areas as an after effect, sort of shock from that droughty summer. The analysis that Marlier did, Marlier, I don't know how to pronounce her name, basically compared that summer to the anomalies, the changes from the historical averages that are projected for the 2040s in the climate projections, and found it was a pretty good analogy to what we'll be seeing as an average summer in the middle of this century. So that gives you a more maybe visceral sense of what that coming climate might feel like and look like. So obviously, those changing conditions are a challenge to those of us trying to establish forests or reestablish forests. And I think in some ways it's, Bree, as you were sort of alluding to, it's sort of a deeper, more fundamental shaking of the foundations of our profession, of our work, because, as I said, it's a kind of work that relies on this idea of bringing things back to a state of health, to us, at least at one point we saw them as, maybe having these very specific plant communities that we could reconstruct that existed before European colonization, that we could find, a historical reference site that we would try and aim for. And this idea that we're now sort of irrevocably moving into a new climate and possibly new optimal vegetation types kind of shakes that foundation, shakes that idea of restoring ecosystems. In the upper right of the slide, you can see a figure of Western North America from Jerry Reinfeldt, who's a forest geneticist, analysis that looked at basically climate types, combinations of rainfall and summer and winter temperatures that correlate with certain vegetation types. And he and his colleagues analyzed where in 2060 there would be areas that there are no current analogs to that climate, those combination of factors. And you can see the gray shaded areas in this map are areas that are projected to have a climate that is unlike essentially any climate in North America currently. And you can see we have in the Puget Sound area, we are projected to experience a climate that has no current analog, which means the optimal mix of forest trees and vegetation that would survive best in that new world also has no analog. So that brings home this idea that we are in this sort of world of uncertainty as restoration ecologists, and even as maybe backyard gardeners and people who have a back 40 they're trying to steward responsibly. And we're led to a number of questions like, what is in some cases an invasive plant there, and what might actually just be a migrant that should be migrating here in a time of climate change? What is damage to an ecosystem versus what is that ecosystem adapting to changing climate? And who decides, what are the functions and benefits that we really want from these changing forests? Those are some big questions that we have by no means answered as a community. But there is a lot of thinking about how to start thinking about it anyway. And Eric Higgs, University of Victoria, kind of put together some of those thoughts in creating sort of this idea of a restoration version 2.0, where version 1.0 was perhaps trying to shoot to just recreate these old historical reference communities. And version 2.0 uses history not as something to recreate, but as something to give us a guide of how ecosystems work and can be put back together. Restoration 2.0 is more process-based. How do we make sure that streams continue to connect to their flood plains and you continue to have diverse ecosystems, continue to have certain fire regimes that don't preclude diverse forests. 2.0 focuses on just maintaining biodiversity of some sort, even if it maybe is shifting composition of species, because that is one of the things that leads to resilience, to ecosystems being able to bounce back from things like fires or human disturbances of other sorts. And Restoration 2.0 asks society more to discuss what our needs are from our forests, from our streams, what it is that we value about our ecosystems that we don't want to change, and makes that influence of societal values explicit. So that's kind of where the field of ecological restoration is going, forced by the changing climate. And sort of as one practitioner thinking about those same questions, I have culled from my reading of the literature and talking to other restoration ecologists, sort of a series of strategies, both larger and smaller, that I think will be helpful to restoration practitioners, people trying to assist the recovery of ecosystems. And hopefully, although I know some of this is maybe seems a little abstruse and focused on environmental professionals, I hope that this can be, informative to folks who are just interested and maybe are gardeners or, working in your own backyard, or maybe influencing your town council on how our, urban open spaces are used and stewarded. Because I think, these apply to some extent across all of those land uses. So the first thing I would say that a lot of folks bring up, especially the Puget Sound Partnership guidance most recently really made this clear, is the first thing we need to always do in planning a new project is ask the climate question. Just to say we need to incorporate thinking and planning and pondering the possible impacts of climate change on every project. And that just needs to be part of the conversation from the first step of whatever we're doing, whether it's planting a streamside to make a new streamside forest, or whether it's putting in a new culvert or whatever. And then I've categorized a few sort of levels of strategies, from kind of smaller project-based strategies to some larger landscape level ideas. And I didn't set my timer as I meant to, so maybe if I start going too long, you can let me know where I stand. But so at a sort of nuts and bolts level, which I think often applies to even small backyard projects, or certainly municipal park projects, and certainly the work that I do and some of you do in ecosystem restoration, There are things we can do when we're asking the climate question at a project level. One of them is to sort of engineer for climate change. First of all, improve our risk assessment for all of our projects. Sometimes maybe is for something as small as, in public parks, one of the hazards are snags or hazard trees, right? Well, if you have a higher turnover of trees because there's more drought mortality, maybe we need to bump up our cycle of risk assessment for hazard trees. Perhaps we need to do a better job of doing risk assessments for flooding impacts for work we do around water passage, infrastructure failures, bridges, roads, revetments. We just need to be more aware that heavier rainfalls in the winter and higher flows during those peak flow times in the winter might lead to higher risk of failure in our projects, both green and hard infrastructure. And that leads to my second point, which is that in addition to doing a better job assessing for future risks, we definitely need to begin over-engineering some of these same projects, again, whether they're green infrastructure, plantings, or hard infrastructure, things like erosion control and bioengineering solutions. And in fact, George Will here at WDFW, the Fish and Wildlife, and colleagues have actually made some very specific recommendations coming out for culvert size, following these same ideas that according to climate projections, a lot of our Washington streams at bank full width, at sort of high-ish flows, will be 5 to 10% wider in the coming century. I think it was maybe a mid-century target than they were historically. They're going to be carrying more water from these high winter rainfalls and then culverts to protect our roads and also to protect our stream health should probably take that into account. So they did some engineering estimates to figure out exactly what those culverts should look like. And I think we need to do more and more of that kind of work to figure out, how do we engineer not only our culverts, but also engineer our plantings? Do we plant them more densely because there's going to be more summer mortality? Do we do more summer watering that, may be considered over-engineering as well? So another important thing and common denominator for all of these is that every one of these is going to cause projects of any given size to cost more than they used to. And I think that's just part of the new cost of doing business in a climate changing world. But doing a better job with adaptive management is also critical. And that is adaptive management, for those of you who aren't familiar with it, is, in a nutshell, it's basically keeping track of what you've done, maybe trying a few different things when you put in a project, monitoring them, and as you see failures and successes in iterative cycles, shift what you're doing to keep following success. And of course, that requires money for monitoring, for instance, monitoring for diseases among our plantings, monitoring how our maintenance treatments are working, whether we need to do more thinning in forests, and keeping track of our successes. And that includes things like keeping up as restoration practitioners with projections about El Nino Southern Oscillation years. When do we expect there to be a particularly dry summer because of El Nino, and planting and setting up watering accordingly. So using those drought forecasts and El Nino forecasts as part of our toolbox for adaptive management will be more and more important. And finally, among the project approaches that I'm going to talk about, and maybe slightly more in depth, is the idea of changing or shifting our plant palette, the plant materials we use. Certainly making sure we're incorporating a diverse range of plants when we're planting, because diversity often is one of the best sort of tools to improving resilience of plantings and of forests when they grow up to drought and other stressors. And then expressly including in that diversity, maybe a little bit of a emphasis on drought-tolerant species, drought-tolerant native species. And here's where it gets tricky and interesting and full of debate, maybe including some genetic types and even species that are not currently native, that is engaging in assisted migration. And so I'll just backtrack a little bit to explain this idea of assisted migration and what restoration practitioners are thinking. It's been known for quite a while now that although at one point we believed, a century ago, that there were fairly static groups of plants and organisms that made up communities that belonged in a certain place. Work by Margaret Davis and other paleoecologists in the 20th century showed us pretty clearly that actually over long periods of time, our forest species and all sorts of other species, it turns out, move and migrate with changing climate. And they do that among trees. Well, there are various ways that plants can adapt to climate. Individual plants can adapt through phenotypic plasticity. An individual plant can adapt to, changing temperatures up to a certain extent. And plants over a very long period of time can evolve with changing conditions. But that this migration is a big way that plants follow climate, so to speak, that after the last glaciation, plants moved up, especially it was shown up the East Coast in bands as the climate warmed after the glaciers. And this is through both movement of pollen, as pollen from more southern populations moves and pollinates more northern populations, and also through seed movement. And the work that was done by these paleoecologists has shown that forest trees can perhaps move 20 to 40 or maybe up to 100 or more kilometers every century. But at the same time, our climate projections suggest that in order to keep up with our changing climate, our forest trees would have to move 300 to 400 kilometers per century to not become maladapted to where those trees are growing, to the climate where those trees are growing. So the math there, as you can see, doesn't really pencil out. What it means is that without our doing anything, a lot of our forests will become, and in fact, there's evidence that they already in many places have become slightly maladapted, poorly adapted to the temperature and climate regimes where they're growing. And so a lot of restoration scientists and ecologists are suggesting that humans may need to play a role in helping to move species of plant mostly northward or upslope in something called assisted migration. And this throws a lot of people into a tizzy, and in some ways for good reason, because there's been no end of trouble that we have gotten ourselves into by moving organisms around this planet. Like some of the worst trouble our ecosystems are in has to do with us moving organisms willy-nilly around the planet. So there's very good reason for people to be worried about this idea, but it's useful to take the idea apart a little bit and consider that there are smarter and less smart ways to go about it. Our Caston Dumrose and colleagues, foresters, forest geneticists, put together this comparison of 3 different kinds of assisted migrations. And I'll start actually on the right-hand side. there are folks who have taken the law in their own hands and decided that, for instance, this plant called Torreya taxifolia, which is sort of a glacial remnant species that only really exists in northern Florida. It's an example of a rare plant that is becoming very poorly adapted to its extant location, should be moved north. And people who are a fan of this plant have moved it into very far-flung places on the East Coast, or East Coast and Midwest, in an attempt to sort of reestablish it and give it a new home. This is a pretty dramatic movement across large portions of a major continent, with not a lot of time to figure out whether they're also bringing along pests that might be associated with it. And this kind of major movement is, could be a source of concern. And as I've said, we've ended up with invasive species all over the place because we've moved plants around in that way. But there are two more sort of cautious versions of assisted migration that are, I would say, qualitatively different, and are things that foresters are actually involved in doing now to try and make up for the inability of forests to move fast enough. So in the middle, you can see the case of a theoretical, or actually I think it's become reality, movement of ponderosa pine north from its current range, shown in green, up into Alberta, where it is becoming, where the climate is becoming more and more amenable to ponderosa pine, and where in fact mountain pine beetle have been decimating the jack pine and other native pine species. And the forest, in some ways, it could be argued, really need an infusion of a better adapted plant. This is kind of mimicking what naturally happens during periods of climate change. Plant seeds, blow all around and blow to the north. And if the climate is better there for that species, they will grow and flourish there, and the species will increase its range, as Margaret Davis showed species did after the glaciers receded on the East Coast. So this is an example of a kind of migration, assisted range expansion, where humans would be helping a plant to move a little faster in ways that probably would be moving naturally anyway. And then finally, an even less dramatic version is something called assisted population migration, where you can see the arrows on this left side for Western tamarack represent moving, not even moving a species outside of its current range, shown in green, but moving different genetic material, different genetic types of that plant from one part of its range to another, because it has been shown that, especially among Western trees, but plants all over the world, within a given species, there are pockets that are adapted differently to their local climates, and that the very northernmost plants in a population are likely less well adapted to warm temperatures, for instance, and droughty summers perhaps, than the plants at the southern range. And that if you were to move seed from those southern adapted populations more northward, they would be likely to be better adapted to the coming climate. And that is what restoration practitioners are engaged in and are considering now, and in many parts of the world are in full swing of doing. One of the tools that has been used to think about where we move plant seed and what's appropriate are these seed transfer zones, which if you're a restoration ecologist are very familiar, which were areas that were considered safe to move plant seed within. So if you were a forester in the Puget Sound area, you had a little delineated area where you could get seed from that should be well adapted to that area. This idea came from the failure of a number of plantings in the early part of the 20th century. Well, they were plantings in areas that were burned off in Oregon and southern Washington in the 20s, where they took huge amounts of conifer seed grown up in the Wind River nursery down in, let's see, I think it's Oregon, southern Oregon and Washington. Anyway, and replanted it across a broad elevation gradient. And then lo and behold, 40 years later, it was found that a cold snap killed off large blocks of these plants that were taken from low elevations, and foresters were woken up to the fact that they really needed to pay more attention to where they took their seed from, and that seed from low elevations was not going to necessarily make for a long-term healthy forest at high elevations. And so they drew these lines and said, all right, if we're going to take seed from one place to another, let's make sure we keep it local. And that has been updated in 2002 to reflect various the genetics of different forest trees. But we're now in the process of having to update that idea again to take into account the fact that we may need to be moving seeds from outside of those boxes in order for them to be successful plantings and successful forests in the coming climate. You can see on the right a little analysis I did looking at in 2050, what areas have currently the climate that we might be seeing in our urban areas in 2050. And you can see specifically urban areas like Seattle and Puget Sound urban areas. And you can see the places that match the summer heat index that we'll be seeing then range way down into Oregon and even California. And so it makes you begin to think that in order to survive future drought in our urban forests, maybe we need to be looking at seed provenances, that is, plants with origins down there. And there are some folks who are doing just that, are experimenting with large-scale restoration like that. An example is up in Minnesota, Meredith Cornett, a number of folks planted over, I think it was 2,000 acres of the sort of failing North Woods, where a lot of the aspens and white spruce are dying back from climate change in northern Minnesota, and replanted with a mixture of a little more warm tolerant native species, bur oak, red oak, white pine, and also experimented with bringing provenances, seed sources from southern Minnesota up into there and planting them. And they have been finding that, in fact, a lot of the oaks and more warm tolerant species, and specifically oaks that come from seedlings grown in a more southern area, are actually surviving better in those replanted forests. And it's interesting, if you, Meredith Cornett writes pretty eloquently about sort of the process of grieving that she has gone through as an ecologist, realizing that her beloved North Woods are not going to come back in the way she or others historically knew them, and that she eventually had to very painfully come around to trying this new approach and to realizing, you know, the North Woods can be a healthy forest, but it won't be the forest that she and others have known. So they are working on that now. And there are actually now some projects right in our backyard following suit. The big one is the Stossel Creek Project, which is a collaboration between Northwest Natural Resources Group, City Light, Mount Sound Greenway, where they have planted sort of our version of that, planted more western white pine, grand fir, white oak, shore pine, and using not only, trying out local provenances, local seed sources, but also some Oregon seed sources, as well as even a little bit of what you would call assisted range expansion, bringing this tree in the center, well, sort of lower right here, incense cedar, up from its normal range that goes up through sort of central Oregon into western Washington. It's very drought tolerant and probably would be one of the species that would eventually move into this area with climate change. And so they're actively trying that out on 154 acres in western Washington. So watch this space. All right. That leads us to just a number of recommendations. I think I'm probably using up my time here, so
You have about 10 minutes. Just
okay, I'll gloss over this a little quickly, but basically there's recommendations beginning to say, certainly in Canada, they are well behind the idea that you can move seed sources 1 to 2 degrees latitude northward. Canada has been very forward thinking in this area. They depend so much on forest products. And then here in Washington, there's the Forest Adaptation Network headed up by Michael Yadrick, who are trying to come to some consensus also on what we sort of smaller scale restoration practitioners should be doing in that regard. So people are on the move, thinking about what the nuts and bolts recommendations should be for where we get our plant materials. I think we're going to need to think about getting them from further south and further downslope when we plant. So that's in a nutshell the idea of how do we change where we get our plant materials. I'm just going to talk about a few other considerations, sort of moving up to a landscape level as we take on these projects. As far as thinking about the goals of our restoration projects, we need to do everything we can to reduce non-climate stresses. So in some ways maybe it's good news. What it means is that keep doing what we're doing. Work on diminishing forest fragmentation, work on retaining diversity and resilience in our aquatic and terrestrial systems. That will help give them some adaptation, some space to breathe as our ecosystems deal with climate change. Work on making sure you incorporate diversity, not just plant diversity, but also sort of functional diversity among different plant types within our ecosystems, within our planting projects. And always think about resilience of these systems. This is something in other talks I've given a little more time to, but I'm going to go through it pretty quickly because I don't have much time. The idea being that we need to think on a landscape scale, which it's going to require collaborating with other partners to figure out what a resilient landscape will look like. And just an example of this is work that was done up in BC, where for a long time they were just trying to thin a lot of their forest stands to reduce and do this sort of even thinning of forest stands to reduce the impact of fire and spruce beetle on them, which seemed to work pretty well on a short time scale. But what they found is that as those forests grew up, they became these even-aged, again, more densely packed forests that actually were highly susceptible to landscape-wide ravages of beetles and fire. And what DeRose and Long sort of came to is this idea that you need to work at a landscape scale and think about the fact that you can't apply this one treatment to the whole landscape, or you, again, get a homogeneous landscape that's susceptible to damage. You need to think about patches that if one is damaged by fire, that there will be other successional states and other community types around it that will react differently and provide sort of landscape diversity. And that provides that creates a resilient landscape, and that requires collaboration among landowners and land managers to create that kind of diverse landscape. I've thrown this in to say that resistance, that is to say, claiming that any particular patch of forests you can bulletproof it from the ravages of climate is futile, but perhaps resilience on a landscape scale is possible. So this is just again saying we need to think on a landscape level, and there are new tools that will help us do that. For instance, this North Pacific Landscape Conservation Cooperative does a lot of mapping on the landscape level of concepts like resilience and diversity that we can use as practitioners. Let me just check. And the last things are thinking on that landscape scale. We need to do a lot of the things we have thought about in the past more carefully, do more vulnerability assessments, and keep thinking about corridors for migration, prioritize those bottomland and aquatic habitats that are already super important for biodiversity, but are ever more important because they're both vulnerable to those hydrological changes that are coming, but also they are centers of resilience because of their diversity. And follow Nature Conservancy's concept of land facets, that is, where there's geographical and topographical and geologic diversity, there will always be biological diversity. So when we seek to preserve land, try and find topographical outliers, prairie soils, serpentine areas, the areas that are always going to be centers of diversity, no matter what the climate brings. And I think the last thing I'm going to say is that we should also make sure we seize the opportunities that climate change brings, which it's so easy to always see the things that are slipping away, but there are also going to be opportunities. For instance, sea level rise projections show that salt marsh areas are actually, potential salt marsh areas are actually going to expand by something like 10,000 or like 9,000 acres by 2100. What a huge chance to go in and work on restoring and guiding the reestablishment of a pretty rare community type in Washington. So we need to jump on those opportunities. All right, that's my laundry list and my thoughts on what restoration practitioners need to be thinking about. I'm happy to take questions now or later.
Thanks, Matt. So just to start out, there's a question in the chat, but if you have a chat, you can either unmute yourself and ask, put it in the chat, or raise your little Zoom hand. So the question in the chat is from Joe, and it says, is there an expectation that there would be more extreme snowfall, in parentheses, heavier precipitation during the winter?
I'm trying to remember again, so this is where I have to say once more that I'm not a climate expert, and maybe James or someone else can jump in if you have better remembrance of these details. I don't recall reading that snowfall is expected to be more extreme. I think that may fall, but I'm not 100% sure on that. Mostly I've been hearing about the fact that whatever does fall is bound to melt off a lot faster and more likely during kind of early spring, late winter, but I'm not sure, I guess, about snowfall projections. Be happy to look into that and see if I can get an answer on that. Circle back.
And Joe gave you a thumbs up. And so Antonio put in the chat, what are your thoughts on planting coast redwoods in the Puget Sound in anticipation of climate change?
Yeah, that's a, um, I was just thinking about that because in the urban parks of Mercer Island, where I used to work in also doing urban forest restoration, there are a bunch of redwoods that someone planted years ago. And I know people are interested in that. To me, that is not kind of the level of movement that a lot of the forest geneticists are recommending right now. That's a pretty huge move from moving an entire species up from California. There are smaller moves we could do first, and a lot of the recommendations of these forest geneticists who are really thinking carefully about this is that, don't try and start planting things for the 100-year ahead projection, because there's just more and more uncertainty in those projections the further out you go. Let's look 20, 30 years ahead and plant, for now, plant things that match that. And don't start with moving whole species unless there's a good reason. Maybe start with moving genetic types of existing native species up here. Let's, start small and let's work our way into this maybe before we start bringing redwood up wholesale. Those are my thoughts.
Thanks, Matt. That was a nice model answer. Are there any other questions anyone would like to ask?
Yeah, this is Joe again. One thing I've been wondering and just kind of pondering is if what y'all think, and if this is like factors into your planning of, as climate change creates more stress, societal stress, stress on agriculture, and more resources have to be put into just us staying alive as a species. And maybe less resources are available for ecological intervention. Do you anticipate that riskier interventions that might be needed over time when we don't have the time and resources to really do things quite as well as we would like to?
Yeah, that's interesting. I mean, that's something I certainly worry about, is that, right, sometimes things like ecological restoration, which seem pressing to many of us, will certainly seem less pressing than food production and some of the more basic needs if things get very stressed by climate change. I mean, to some extent, I think we've been building a pretty good case that a lot of the work we're doing in restoration actually provides really important human health benefits that align with the things we are going to really need as basic needs, as places for people to escape in urban forests that are cooler. And obviously, as people become more stressed, they will need stress outlets more, and the existence of natural systems, healthy natural systems, is super important for people's psychological health. So I think more and more, we realize that it is one of our basic needs to have functional forest and stream ecosystems. But at the same time, I think, it's fair to worry about the resources we'll have to put into these. However, I'm not sure that necessarily drives us to doing really extreme interventions, because I think extreme interventions also run the risk of catastrophic failure. And I think we could even less afford catastrophic failures if we have fewer resources to go towards fixing them. So I still think that a fairly cautious approach is probably the best we can do. Does that answer your question?
Yeah, thank you. That's a great answer.
I'd also like to add that question speaks to the larger need to re-envision our food systems also. It just shows that we don't have a sustainable method of producing food for everyone right now. But thank you, Christian. Good answer.
Could have a whole, another whole segment about food systems for sure, if not 10.
Yeah, definitely. Okay, any other questions? I think I have scheduled 1 more minute for this section. We're right on time.
Great.
Okay, well, thank you so much for that presentation, Matt. Really interesting.
Yeah, sure.
I think that we'll transition to James. Are you ready?
Okay, I'll stop sharing here.
Thank you.
Yeah, I'm definitely ready. And let me go ahead and share my screen. Here we are, and then I'll switch to. Okay, there we are. So hello, everybody. Thank you for having me. I interviewed David Beastock for a piece I wrote earlier this year for my school's blog. So it's nice to finally meet actual DNDA people, if not in the flesh, over Zoom. So I appreciate that. So my talk today is titled Floating Wetlands in the Duwamish River, Preparing for Climate Change with Novel Ecosystems. My name's James. I use he, him pronouns. I'm at the UW School of Marine and Environmental Affairs, which we call SMEA. And I just want to say I appreciated the land acknowledgement at the beginning. I urge everyone to go check out realrentduwamish.org and contribute if you can, or if you cannot, to at least spread the word. It's a great program. So I'm going to start off today by telling you a little bit about how I started to get interested in wetlands. I'm from Redwood City, California, and this was 8 years ago. I organized a protest outside of Cargill's headquarters in Redwood City, or specifically the headquarters of their development firm, which is DMB. And we were there to protest the building of thousands of homes on salt marsh habitat in the San Francisco Bay. So just to orient you, this is where, in the red circle, that's where the Cargill wetlands are located. They're called salt ponds because so Cargill bought Leslie Salt, they produce Morton salt. And so these salt marshes were converted into ponds for salt mining, essentially. And Redwood City is not labeled in this map, but it includes that red circle and places to the kind of southeast of that circle. And so this is just a close-up look of where those wetlands are. And so the question was asked, or the question was forced by Cargill as to whether or not these are wetlands. If you look at this photo here, this looks like an industrial site. They made the argument to government agencies that this is not a wetland, this is a working area. So Clean Water Act provisions don't apply. We could totally build homes here, why not? But I just wanted to show you how this area looks at high tide. If you go right up to the fence, looks like this. You can see it's totally inundated. And you can also see tons of, or well, not tons, but lots of migratory birds in this photo here using this habitat. Sorry about that. I forgot that this has my audio on it from a previous presentation. So yeah, so repeating myself, wetlands are important because they give you habitat for juvenile fish. They provide flood control, erosion control. They stabilize shorelines. And they also provide water quality functions in that they help sediments settle out of the water. There are different heavy metals or other contaminants that can be sequestered in wetland sediments. And you also have carbon sequestration benefits from wetlands. And I think, yeah, yeah. So there are still audio clips attached to these slides. Sorry about that. So just wanted to show you a photo of the lab I worked in the San Francisco area. We worked a lot in salt marsh habitats and in eelgrass bed ecosystems in the bay. And this will become relevant later. And so briefly, I just wanted to talk about why I love doing restoration work. One, I consider it kind of simple but effective in the fact that you can make very simple, at least in my mind, simple changes to an environment and get quite drastic or significant results. And so this is one of the projects we did out in San Francisco Bay, where these little concrete blocks were placed out in the low, or I should say high subtidal range, just below the intertidal zone. And you can see some fiber matting inside, balled up inside these concrete blocks. And they were used so that we could get oysters to settle out and recruit. And this is what one of those blocks looks like after some time in the water. So just changing the structure, putting out essentially a piece of rock can give you the beginnings of an oyster reef. This here is called Suede Californica. It's this kind of gray, flaking plant that you see going kind of on the lower edge of the top photo and up the fence in the bottom photo. So this is a plant that grows in the high marsh, in salt marsh habitats. It's an endangered plant. And it also, because it grows high, it provides some level of high tide refuge for endangered species like the salt marsh harvest mouse. And one restoration tool that we started using in our lab was not fences, but we started placing branches in the ground, thick eucalyptus branches and smaller kind of trellis branches into the ground next to these Suede plants to give them some sort of arbor to climb up. And so this is another example of just small, simple changes you can make to an environment to make a plant grow taller, to make it a plant that provides more high tide refuge, so on and so forth. And fieldwork, of course, is always great. I'm not very coordinated at like hand-eye coordination type sports, but I love kayaking. I love getting my heart rate up, and fieldwork is a great way to do that. And you also get great views at all different times of the day. This particular one is my friend Gina out near Oakland serving eelgrass beds. And so what about climate change and what about the local context here in Seattle? So my work is in the lower Duwamish River in Seattle, in South Seattle. There are lots of things going on there, but climate change is, of course, going to bring a sea level rise and warming temperatures. And that's going to happen here. This is what, this is a pit photo from one of my research sites in the lower Duwamish River. And this great diagram is from a presentation by some students at Seattle University, but I want to present it to you here. So you see outlined in white the current state of the lower Duwamish River. It's officially called the lower Duwamish Waterway because the river is essentially no more. It's been channelized, it's been industrialized, urbanized, concretized, colonized, all these terms that have changed the ecosystem function here. And so you might be able to see there's kind of a small island and just to the lower left of the center of this photo, there's a small island that you can see that's Kellogg Island. And here's a photo of Kellogg Island. And the little stretch of river to the left of Kellogg Island, that's the last remaining original bend of the Duwamish River pre-settlement or pre-white settlement, I should say. And so for background, the Duwamish River is part of the Duwamish Estuary, and it's part of this larger green Duwamish watershed. You've got an upper Green River watershed, you've got a lower Green River sub-watershed, and then as you go further down the watershed, things get more and more urbanized. There's a lot more issues with pollution and contamination, and then you reach eventually the Duwamish Estuary, Elliott Bay, and Puget Sound. The diagram on the right shows you the same kind of a zoomed in picture of the lower Duwamish. And the shaded areas are just showing the combined sewer outfalls. So essentially, if you're in that sort of purple shaded area and water goes into a storm drain, it all kind of flows out to that little point in the Duwamish. And so because the river has been channelized, there's a significant loss of ecosystem function. We have a lack of shallow water habitat for juvenile Chinook. There are a lot of contaminated sediments, not just in the river, but also upland in the soils, cement, kiln dust, PCBs, all sorts of stuff. And industry continues to pollute the river. There are regulations in place, but that doesn't stop pollution from happening. And the air pollution from industry in the area also impacts public health. There are a couple of things that happened in the last within the last 20 years that have really kind of helped kickstart the move toward restoration in the lower Duwamish. That includes the fact that local Chinook salmon were listed as threatened under the Endangered Species Act. And also in 2001, due to community pressure, activism from groups, including the Duwamish tribe, this area was listed as a Superfund site. And so we have now the Lower Duwamish Waterway Group, which is responsible for sediment cleanup and restoration, and the Source Control Work Group, which is led by ecology, and they control pollution inputs into the river. And just to go back to what I said just a second ago, so pollution still keeps happening. This is a little notice from Puget Soundkeeper about a settlement with Seattle Iron and Metals for pollution that the company was responsible for. Here's a news article from the year before that, calling out Boeing for polluting the river. And this is from last year. Another company called Ardag Glass was found to be polluting the river. And so if we look at all the different causes that might be causing these issues, and we want to think about what the actionable causes, the things we can take action on to change actually are. I listed those here kind of in orange. This is something I did for a policy analysis class. It's called hierarchical analysis. But the main thing to keep in mind is that we can think of the problems that the Lower Duwamish faces as natural events that would normally occur, such as storms and king tides. And then you have anthropogenic human-caused events, such as all the consequences of settler colonialism, all the consequences of climate change, which is, again, human-caused. And breaking these elements down into actionable causes, what we come up with are things we can actually work on, which are this altered flow and loss of habitat for salmon, urban and industrial runoff, contaminated shorelines, and not just contamination of these shorelines, but also further inundation of these shorelines, right, due to sea level rise and more extreme flooding events. And just in general, more juvenile salmon deaths from whether it be from warmer waters or these other stressors that are listed. And so I want to talk a little bit about restoration in an urban context. This is from Seoul, South Korea, where my parents are from. And this is called Cheonggyecheon, which is the literal translation of Cheonggyecheon is like essentially Clearwater Creek. So this is how Clearwater Creek looks now, but before 2005, this was a stream that was completely covered by a massive freeway. So this is very different now. And so there were a lot of concerns at the time when this project was put in place to kind of restore Cheonggyecheon and make it this kind of public walkway, this public kind of thoroughfare. There were a lot of concerns about that related to not just your normal political concerns, but also just the fact that environmentalists were concerned that this effort wasn't going to turn the stream back to some sort of original historical, authentically historical ecological state, right? Because historically there weren't these walkways, and also the stream itself. The stream was actually created centuries before to divert wastewater. So the stream itself also did not, was not a natural naturally occurring stream. It was a man-made stream to begin with, but there were still these concerns about, oh, how can you say that we're going back to a proper, clean, authentic state? But everyone loves it now because it's provided green space, it's provided public access to the shore, it provides educational opportunities on ecology, environmental concerns, climate change, so on and so forth. So there are benefits to this restoration work, this huge project that took about 10 years, I would say, to fully complete. And even though it's not bringing this stream back to whatever you want to consider its original state, it's still a massive benefit to the city. And so how do we take those ideas and that kind of vision and those kinds of goals to the lower Duwamish when you have a river that looks like this at the moment? Well, what we did, or what I and my colleagues did as part of my research, was we deployed constructed floating wetlands into the lower Duwamish. This here is a biobarge, this kind of wooden frame structure that is hanging off the end of this metal dock. And this dock is actually Waste Management's dock. They were kind enough to let us use their facilities to access this dock and to place our biobarges here for part of the summer and spring. So what you see here in this biobarge are 4 large cubes in the center. We called them biofilters, and the 4 larger cubes were actually deployed with the wooden frame as one structure last summer by a different set of SMEA students. This summer, we placed these biobarges back out into the water, and what we did was we added these smaller biofilters on the edges. Now, floating wetlands are used already in wastewater treatment plants. They're put into these treatment ponds to help draw up heavy metals or other contaminants from the water. And also natural floating wetlands exist as well. You can go to bogs and you'll see floating rafts of plants that may not necessarily look floating because there's all this litter and stuff on top, but they are sitting on top of the water, and the floating wetlands could be maybe 1 meter thick, maybe 3 meters thick. That substrate, the thickness of that substrate can vary. So yeah, these biobarges are made with mostly natural materials, wood, metal, so on and so forth. You can see though, for the smaller biofilters we put in along the sides of the biobarge this year, there's some black plastic, the Tensar that we used. And we deployed these in 2 sites. One was in the lower Duwamish itself, and then one was a little further upstream, just off of a private dock in Tukwila. And that was partly just to see what sort of differences in performance we would see on a more upstream site versus another, but also partly just due to permitting limitations, which I'll get into later. And so these are the materials that went into our 1.0 biofilters from the previous summer. These are all natural materials, well, wood, metal, biofoam created from mushrooms, essentially. And then this was our smaller 2.0s, which I actually had a hand in constructing with some other students. And it's just a lot of wood straw, pumice blocks for flotation and buoyancy, this black plastic Tensar to keep everything in place, and plants were planted into the top of these little biofilters. And so the questions we were asking were, well, one, will juvenile salmon actually utilize this as habitat? Because there are concerns about how juvenile salmon, because their vision isn't great, if they see a hard shadow, what tends to happen is instead of going under that shadow, they'll swim around it because their eyesight can't adjust immediately to that abrupt light change. And if they can't see properly, they can't see predators. So if they see a hard shadow, they will tend to swim around it. And there were also concerns about predator fish as well, and that, hey, these might provide a lot of shade and shelter for predator fish too. Will they be just, hang out there and try to pick off juvenile salmon? And then there were more general questions as to whether or not these things actually perform well. Like, do they actually function? Like, do our wetland plants that we planted into these biofilters actually grow and flourish? Are there benefits to water quality? Are we seeing more invertebrates that salmon might want to eat, like, flies that might land on one of these plants and then, accidentally drop into the water? Are we seeing more of those types of insects? So on and so forth. So those were some of the things that we were asking ourselves when we were monitoring these wetlands. And here's a picture of one of my colleagues, George. I think he's about to take some water quality readings. And again, this is at the waste management site. This is on, if you want to orient yourself, this is on the opposite side of the dock that's pictured in the right-hand side picture. So it's facing the opposite direction. So just to keep things short, I'm going to skip to this slide. And so there were 4 things we were looking at essentially. We were looking at benefits related to fish. We were looking at performance related to plants. We were looking at water quality, and we were looking at invertebrates. Those were our 4 elements. And so the main question we wanted to ask was, do juvenile salmon, will they actually use this habitat? And so yes. And so we had GoPro cameras underneath our biofilters, or next to our biofilters. And what you can see here in this image is a tiny little juvenile chinook opening its mouth, trying to feed. There's probably some smaller invertebrates in the water column that it's trying to pick off. Very cute. And the question that went along with that was, are there concerns about predator fish? Essentially, no. Like, there was one time when we were out monitoring where they did see 2 sculpin, but literature, everything we've seen in literature has said that yes, sculpin will eat juvenile salmon, but it's kind of an insignificant part of their diet. So it's not like they would necessarily be targeting juvenile salmon. And we only saw those 2 sculpin once during the entire monitoring period. Will wetlands plants grow and flourish? So this is complicated, and this was actually my main focus. We had a bunch of folks monitoring these wetlands, and the plants were my focus. And what we noticed was that for the wetland plants, I'm going to flip back to the next slide, or to the previous slide, just so you can see the plants again. For the wetland plants, these were all native plants. They're adapted to being inundated, to having their root system submerged, and they're adapted to being in tidal habitats. So we were pretty confident that they would work out, but we weren't necessarily completely sure. So what we found that yes, there are differences in plant performance, but the thing that seemed to affect plant performance way more than anything else was, particularly at this site at Waste Management, was just the insane amount of vessel traffic and the boat wakes that traffic would cause. So the plants, it wasn't necessarily water quality that the plants were having a problem with, it was just being hit by these massive boat wakes. And so this entire frame, the structure would start jostling, and all these tiny little moving parts, these little biofilters would start bumping up against each other. And that would kind of harm the integrity of these biofilters. And we noticed that for instance, the biobarge that George is standing on, that was facing out more towards the water than the one in the right-hand photo. So we saw a lot more, we saw a lot less plant growth in that biobarge than we did in the one on the right-hand side. And both of these biobarges in both of these photos also had a side that was kind of more front-facing out towards the boat wake. And so on the left-hand photo, the front-facing side was the side that George is not standing on, so the opposite to George. That was the side that was the most heavily impacted by boat wakes. And for the right-hand photo, the side that was most heavily impacted by boat wakes was the side along the top of the photo there. And we noticed there that, so yeah, being in the direct path of these boat wakes just really gave these plants a beating. So we found that was kind of an interesting and kind of unexpected part of doing this research, at least when it came to the plants. So we do think that these plants can grow and flourish, but yeah, location is a big issue. And are there benefits to water quality, and are there more invertebrates? I put it's not a no here because we did see some upward trends, and, like, you know, yes, there There were more invertebrate species that salmon like to munch on in and around our biobarges than at our control sites. And our control site was just a bare dock with nothing attached to it. But there was no statistical significance. So we can't say that the difference we saw actually meant anything. So not a no, not a yes. Are there benefits to water quality? So that these biobarges are at such a small scale that these wetlands aren't going to clean the Duwamish River, right? But what we found from our water quality metrics was that everything we were seeing within our biobarges said that all the concerns that one might have for juvenile salmon, like warm temperatures in the summer, low levels of oxygen, because that's often a huge problem in nutrient-rich waters. We didn't see that at all. So all of our metrics for water quality seem to indicate that salmon would do just fine in this part of the lower Duwamish. And also light too was another thing that George, our water quality lead, was monitoring. And we found that the light levels were not super impacted by placing these barges out onto the water, and that they would not impact whether or not juvenile salmon or other fish would use them. And I wanted to give a quick shout out to our community scientists. So we started our field work right as the pandemic hit, which meant we had to really scramble to put COVID protocols in place. This is Ayana, one of our Doris Duke scholars. You can see she has a mask on over her face, even though we're outside and there was only one other person with her that day. So we had to really scramble to get a new protocol in place for monitoring. And we also had to limit our own time out in the field as researchers. And if it had not been for our partners in the community stepping up to volunteer their time, this research would not have been possible at all. And so just briefly, what are my recommendations based off of what I've been seeing and some of the other research that I've been doing related to policy around restoration of the Duwamish? I've kind of outlined it here, but I really want to emphasize that we need better enforcement. We need resources dedicated to that better enforcement. So like I mentioned, Seattle Iron and Metals was a company that Puget Sound Keeper sued, and last year they agreed to a $1 million settlement. I checked what Seattle Iron and Metals makes in profit annually. It's $30 million. So, and this 1 million is being spent over the course of a few years, right? It's not like a one-time fee kind of thing. So for a company like Seattle Iron and Metals, that's essentially the cost of doing business, right? They can afford to keep polluting, keep paying fines if they get caught, and keep doing what they're doing. So unless there is, we could also talk about, raising these fees a little, these fines, but unless ultimately there's better enforcement of these regulations, this pollution is not going to stop. And we also need better enforcement of vessel speed and vessel traffic regulations as well. This is not just for smaller scale, floating wetland projects like my own. Our project site at Waste Management was we were across from a slip from a restoration site that was funded by Boeing. And they have this really great fresh sediment cap there. There's lots of birds using that site already. But you can imagine just if these boat wakes are causing this much damage to the shoreline, what would they do to new restoration sites that are done in a more traditional way along the river? So I feel that better regulations are needed, or if those regulations are already in place, I'm not sure. There needs to be better enforcement of them. And also going back to this whole thing about location when it comes to our floating wetlands, I think for these types of novel ecosystem techniques, it's really important that we have the options and where we place them. And that ties into one of my little bullet points that I have down below regarding change in regulations. So we had a really hard time citing these floating wetlands because the permitting process around putting stuff into the water is really tough. And that makes sense. You know, you don't want anyone just putting a random structure out into the river. That's not great, but there needs to be some sort of streamlining so that these projects, which are, you know, kind of more in an experimental stage, testing things out, but at least have been shown to not harm the river. I think, you know, I think the results of our research show that these don't harm the river. They don't harm juvenile outmigrating salmon. There needs to be change in regulation so that we can, we have the option to place these in more places. In a place like the Lower Duwamish, obviously, ideally, you know, my, you know, super high level ecotopian ideal would be like, let's rip out all the concrete. Let's, you know, restore this, at least some of this back to a super, you know, natural unconcretized state, but that's not going to happen immediately, right? That's not going to be politically feasible. And with the climate impacts we're already seeing, we need things to happen sooner, right? And so these floating wetlands or other projects like it could provide that sort of immediate solution. But in order to have that solution be effective, we need options as to where we can place them. And in order to do that, there needs to be some sort of change in permitting and regulations. And the last thing I would just mention is aesthetics and materials. I think it's really important how your restoration projects look. I will admit that our floating wetlands didn't look that great. You know, they looked very industrial. They almost looked like debris, right? In some sense, with the plastic sticking out of the water. And aesthetics matter. If you're putting something out into an environment, out into the community, you want it to be inviting. You want it to, you know, actually draw people to the river. And you want it to encourage people to use this public space. And those are considerations that need to be taken into account as well. And so whether that means, I know some of my colleagues that I was working with, they're now thinking about maybe taking these smaller biofilters that we created this year and maybe placing them along the sides of, you know, finger docks, you know, small docks, so that you have some greenery next to a dock space. And sometimes in a harbor, there are just some parts of a harbor where, or a marina where there's this weird, you have some weird angle and there's this weird like little alleyway where boats don't really go. It's just this kind of dead, empty space. Maybe that could be a good place for some of these structures to be placed, and so on and so forth. So that's some of the things our team is thinking about now and what we're taking away from this project. And so that's all I have for you today. But before I wrap up, just want to thank my PI, Dr. Cleo Wolfley-Erskine, my SMEA colleagues, Samantha, George, and Daniel. Especially thank the community scientists. Again, research would not have happened without them. And also want to thank, well, everyone listed here, but in particularly King County and the Rose Foundation, because they both were funders of this research project. But yeah, thank you very much. And yeah, happy to hear any questions.
Thanks, James. It looks like there are a few questions in the chat. Would you like me to read them? I'll read them out loud.
Yeah, could you please?
The first one is from Joe, and they asked, why are there grates on top of the biofilters and why not leave the tops open?
That's a great question. So we had grates on there because what they found in the monitoring last year was that Canada geese love to graze on these plants. So we had to have some sort of like lid on top. But what we did notice was that at our Tukwila site, the plants were doing a lot better. I think partly because some of the plant species we selected would do better in lower salinity conditions. So they were doing better at Tukwila for that reason. But also there's less vessel traffic. There weren't really wakes. So the plants there were really flourishing. And what was happening there was because they were doing so well, they were hitting kind of the top of that lid and they were kind of getting caught up in that, right? And so we did some, what we term adaptive management, which is essentially, fixing your problems as you go. And so, yeah, the Tukwila site in particular, those lids were replaced with more open caging and placed a little higher, but they were still, for some of the biofilters, it was still too restrictive. So yeah, that's why the cages are there, but that's another thing that we're thinking about when it comes to design. That needs to be tweaked for the next time around if this project happens again.
Great, thanks. And Joe also asked, have your biobarge experiments been large enough and for long enough to get a sense of if they are more or less vulnerable to invasive plant species becoming established?
That's another good question. So one of the things, another takeaway that we got from this monitoring was that, yeah, these experiments are at a scale where it's just really hard to get statistical power. So when it came to things like, did plants do better on the exposed side of a biobarge that faces the boat wakes versus another? When it came to things like that, it was very clear. We had good statistical power for that. But for things like which species did better at waste management, which species did better at Tukwila, we did not have statistical power. Like you would need to put out, so we did like height measurements of plants, and normally what we would do is we would take the tallest plant in each biofilter. In order to get good statistical power, we would have had to have measured the height of every single plant in every single biofilter. And there were 16 plants in each biofilter. So that's a lot of work. So it can be done, but it's, again, it's a matter of resources. And to the question of invasive species, we actually did not see a whole lot of that, which is encouraging. So we had used 8 different species of native sedges, which are like grass type plants, which include bulrushes. Yeah, we didn't see a whole lot of that, particularly at the Tukwila site where conditions were a little better. We did see some plants coming in and colonizing, but they never took over. And I think it was because we had a dense enough planting of the of our plants that that never happened. But another thing too that we noticed was that the plants we planted this year were maybe between 2 to 8 inches tall, and then in the larger biofilters that we had left over from last year, those plants were planted last year, so they were still growing. So they were much taller to begin with. And what we found was those plants did way better than the plants we planted this year. So it really speaks to how these plants need time, these projects need time. They need to be out in the river for a longer period. Again, this goes back to permitting. They need to be able to be out in the river for a longer period so that you can actually see these benefits over the long term.
Yes, thank you. DNDA can commiserate with your issues with permitting.
Yeah, I can imagine, yeah.
So Erica had a question that says, in regard to your question about are there benefits to water quality, would larger floating wetlands result in greater changes in water quality? And what are the sizes of these floating wetlands? Materials inoculated with mushrooms, such as oyster mushrooms, result in water quality?
A lot of good questions. Yeah, so yeah, I think larger floating wetlands would definitely provide more benefit because of the scale. So the size of our biobarges was, I would say they're like 8 feet on the narrow ends and I think 12 feet on the longer end, something like that, 12 to 16 feet. So, and they were like essentially walkable platforms. But yeah, so when it came to scale, we only had 2 of those barges at Waste Management and then 2 at our Tukwila site. So scale-wise, you're not going to see a whole lot of water quality benefits. Water keeps flowing down from the upper watershed. But we have seen, there are studies coming out now, right, about how at least at the local scale, at the scale of a single like eelgrass meadow, you can see some localized benefits when it comes to ocean acidification. So I would imagine that, yeah, if this was at the scale of like maybe 1 eelgrass meadow, then yeah, we might see something similar. when it comes to the material inoculated with the mushrooms, yeah, I think so. The thing we used that was called mycoboard, yeah, that was made from mushrooms, and interestingly enough, one of our biofilters actually grew mushrooms this year, so it probably wasn't treated with heat enough to stop that from happening. But yeah, I haven't considered like putting mushrooms out as a way to actually improve water quality. That's a really good idea. The mycoboard that we used was essentially, it looks like styrofoam, and it was essentially just used as like a stabilizing substrate. And it was used because it's natural. I believe, I'm not sure, because this was one of the folks from King County working on this project. It was kind of his idea to bring on the mycoboard thing. I think they also provided nutrients to the plants, but I can't say for sure. I do know that part of the reason we did not use that this year was because it's a very expensive product. It came all the way from the Netherlands, and I believe they're also not making it anymore. So a lot of constraints. And that also goes back to the question of materials, right? Like these biobarges are going to be way less feasible if you have to import stuff from Europe to build them. So our little smaller biofilters that we were able to put on the edges of the biobarges, I'm really more excited about that, just because they were so easy to build. As long as you had the right materials, we could, like we had like a little workshop class where like maybe about 10 students would build about 10 to 15 of them in a day. They were pretty easy to build. And so I would like to explore that more. Like I know, kind of going back to what Matt was saying earlier about how we need, really large scale efforts at restoration to really truly be effective. But like I could imagine, those tiny biofilters, if we had like 100 of them, deployed at a marina somewhere, what might that do for water quality, So, yeah.
Thanks. Oh, Matt, do you have something to say?
Yeah, I was just going to ask sort of a follow-up on the scale issue, maybe follow up to what you were just saying, what Erica was asking. It seems like you would need to scale up to larger floating meadows to make a substantial impact of any sort. With the question of the wakes and water movement, I think about a lot of natural floating wetlands tend to be in very stable, calm environments. Have you thought about whether there's any sort of woven substrate or a particular kind of shielding wall or something that could float alongside it that might protect those from being broken up? It seems like the larger you make it, the worse those wave problems are going to be.
Yeah, the more and the more moving parts too, just because they were just like kind of like clipped on along the sides versus being integrated into the structure. Yeah, I think I'm not necessarily I'm not so sure about like a wall structure, just because there were concerns about shading and like sheltering predators and stuff like that. I think that's been a big barrier with permitting. At least that's what I've heard from one of my PIs on this project. But yeah, to the question of scale, like, I mean, it also depends on, like what your goals are too, right? So if your goal is to like, we want to like wholesale remedy, the water quality of the Duwamish, then yeah, you need this on a larger scale. But if the idea is to assist juvenile salmon by creating these little kind of rest stops on their journey as they, leave the Duwamish, go out to Elliott Bay and to Puget Sound, if we can create more rest stops for them where they can kind of relax, enjoy, less of a lower flow of water and, and maybe feed on a few invertebrates before moving on. If that's the goal, maybe small scale is fine, and so, and we kind of see that with, the big seawall project, right? That happens, that was completed at the Seattle waterfront, where it was a big project, but it was essentially, if you break it down to its component parts, the seawall, they put these little shelves, right, at different locations all along the wall, all these little shelves where salmon could kind of use as, it raised the river bottom up so that it made this more shallow habitat. And so, and it wasn't like this huge, long, shallow bank that they created. It was these small little pockets, these little stops. So yeah, I think it's really depends on what your goal is. And if the goal is to benefit salmon, I think the smaller scale is sufficient. Yeah.
Cool. Good questions. Good answers. There's a couple more. So Heather asked, do you have funding to continue this project?
No, this is the end of it. So yeah, if someone else wants to take it on and find funding. So my PI at SMEA is my PI for SMEA, but I also have a PI for the Green Futures Lab, which is a lab in the landscape architecture department. And so they were the one who secured the funding for this project and initially piloted the biobarges last summer. And so they are moving on to a new project, which involves looking at like making improvements to doing these smaller restoration type projects in Lake Washington and maybe Shulshul Marina. So that's where their focus is going now. And so, you know, if I can be critical of my own, you know, colleagues for a little second, like that's something that, you know, researchers need to take a look at too. It's like, you know, does it really make sense to do this research for like 2 years in a community and just leave, right? So it's, you know, for these types of projects to be effective, you know, there needs to be a focus, because like we only just now, after 2 summers worth of research, have figured out, okay, you know, now I feel really confident about saying this will work, this will work, this will work, this will work. But now, we've moved on to something else, right? And so that's problematic. And so for this to be effective, yeah, we need to start thinking about funding more in the long term. And we also need to create space in academia for folks to be like, no, you can have, you know, a 10-year or 20-year research project. You don't have to keep moving on to the next shiny new thing. I think that's really important.
Great, thanks. And there's one more so far. Joe asked, beyond these biobarge experiments, does this project lead you want to investigate? And what piques your curiosity?
Ooh, that's a good question. So this, so something Matt mentioned about genetics just kind of made my ears perk up a little, because another project I'm working on at the moment is related to eelgrass ecosystems. I love eelgrass. It's actually what I mainly worked on when I was working in the San Francisco Bay and doing restoration work. And one of the things that the research group I'm with are looking at now are whether, so there's this disease called eelgrass wasting disease that infects eelgrass, and it could, folks aren't sure if it's gonna be a huge problem or not, but what we do know is that more and more eelgrass is being infected with this disease. And so the research group I'm with now, we're looking at whether or not being exposed to this disease causes any changes in genetic expression in eelgrass plants, which is pretty cool because it's kind of taking a more genomic approach to restoration and trying to see if any of the information we get from this analysis tells us anything about how restoration needs to work. And that goes back to the question of genetics, right? You know, maybe some plants are better adapted to handling these environmental stressors. That's something that could be looked at too for like the 8 wetland sedge species that we put on these biobarges. Maybe there's genomic techniques that we can apply there too. So yeah, that really piques my interest. And just on a more broader level, I would also say just what I really love about this work is that it was a way for me as an undergrad to connect with nature and to connect with the spaces around me and to know my community and my environment better. And for me, I think that's what restoration really provides. It's not just, you know, climate resiliency or ecosystem resiliency, it's community resiliency, right? And so any way that these projects can be tied into community engagement, community work, that really interests me. Yeah.
Awesome. Thank you for all those great answers and the questions, everyone. I would like to create space for everyone to answer or to ask any more questions that they would like, but I'm just gonna pivot for 1 second to put a link in the chat. And this is the post-survey link. And this is incredibly helpful for grant reporting and makes my job of figuring out like, not just my job, but like the community that we're serving and reaching. So I'll make sure to put it in the chat at least one more time. And once again, the floor is back open for any questions anyone may have for James or Lee. Yeah, and if not, then we'll be done a little early. I guess I have a question, and I think it was touched on a little bit about like where the project is going. It's for James. Has there been any like thoughts or interest in like putting these sort of floating wetlands into a more still marine environment so that you could maybe like track the level of cleaning and benefits that are there?
Yeah, that's a really good idea. Like these are used in like wastewater treatment ponds and stuff, but to like actually, yeah, have them out in the field and track them in a more still environment, that would be really cool. I do know I've seen some floating wetlands in kind of more pond type habitats. Like we actually observed them for, as part of that workshop where I was building the biofilters. So I do know they exist, but whether they're actually being researched or not, I don't know. Yeah, and so the Green Futures Lab, I know they're looking to put stuff out into Lake Washington and Shilshole Marina. So there might be some of that happening there. But I'm honestly not sure because that's like a different team. But yeah, it's definitely a good question for sure. It should be studied.
Great, thank you. Thanks, Anita. I think Alexandria asked, I think this is just for the general, can any of you connect me with restoration research community-based projects in Northeast Seattle? I feel like that's maybe James, you're right over there.
Yeah, I actually live in Northeast Seattle. I'm in Greenwood. I know that so Thornton Creek is Seattle's biggest watershed, and then Longfellow Creek near where the NDA is the second largest. And yeah, so I think there's some restoration work going on at Thornton Creek, but I'm not sure. But yeah, I'll put my email in chat. I'm not sure, but I know people who would know. So if you email me and are curious to get connected to folks doing restoration work, yeah, feel free to reach out.
Yeah, I would just throw out there also that I don't know to what extent you are specifically interested in just restoration focused work, but there's also community science opportunities through Woodland Park Zoo. For instance, their amphibian monitoring program, where if you're interested in monitoring a wetland in Northeast Seattle, you can find one. In fact, I think we've got like, I think there are a few already there being monitored, but they've also got urban carnivore projects. The zoo is a great source for community science opportunities. And then, organizations like Earth Corps and Mount Sound Greenway and Forterra often have, and Seattle City Parks often have just restoration volunteer opportunities all around the region, including in Seattle. So those are trees to bark up.
So there's a couple more questions. I think this one's for Joe, or wait, no, sorry, for James from Joe. What makes these floating biofilters float long-term? Is it the wood that's not waterlogged yet, or the parenchyma in the plant roots and rhizomes? And the parenchyma are an adaptation in wetland plants that help them breathe underwater.
Thanks, yeah. So yeah, the wood does float-ish on its own, but to help with buoyancy, we placed pumice blocks in as well. And the pumice blocks, they're essentially like, if you look really closely at them, they're man-made pumice blocks. So they're essentially a lot of tiny little glass bubbles. So they're very, very, very buoyant. So So we place those in there for insurance, but the idea is that, yeah, long-term over time, as the plants develop, I don't know if it's the parenchyma so much as it is just the type of bacteria that would produce oxygen or other gases, and those gases would get trapped under the substrate layer. That's my understanding of how some of the floating wetlands that we observed out in some bogs in the Seattle area work. So I think that's the general idea, but yeah.
Thank you. Heather would like to ask Matt, do you have a similar type or scope of restoration project like James's that you would like to share?
I don't think we have anything quite as wildly creative as that project. That was pretty amazing, James. But we have, I think, a lot of cool projects going on up and down, mostly in the Snoqualmie River Valley. So we do a lot of riparian streamside restoration, sometimes with partners. We're excited about some work we're doing with the Snoqualmie Indian tribe at Fall City. There's a huge levee setback where one of a number of big county led projects where they're moving levees along the river back to increase access of the river to a lot of floodplain that it hasn't had access to for 100 or 70, 80 years. And so we're doing a lot of planting back native floodplain forests in sites like that, and in some wildlife management areas, as well as on the property at Oxbow, which is along the river as well. And some of the maybe more interesting things we're doing is we're doing some monitoring of the ways that birds and amphibians specifically are accessing and using those restored areas, and doing some research on the effects of that restoration on wildlife occupancy and use of ponds and forests. So that's a lot of what we've been working on the last few years. We do actually have just one other experiment, again, which your work, James, sort of inspires me to take a second thought on, is also working with a variety of sedge species to look at how we can, to some extent, suppress the growth of reed canary grass, which is a major wetland invader in local wetlands, and using the variety of different sedge species that seem to actually compete to some extent with the reed canary grass in various combinations with soil covers of different types and with willow plantings, and kind of trying to suss out what combinations might add some diversity back and some habitat value back into some of those invaded wetlands. So,
that's really cool.
Yeah.
Great, thank you. Joe asked Matt, is there commercially available sedge seed mixes for native wetlands?
There are, and to be honest, I haven't done a lot of planting by seed, partly because we have so much flooding in sort of high velocity, often scouring flooding. So we tend not to do our wetland planting from seed on our sites, but I do think maybe, is it Fourth Corner? And there are a few places, and this is why the fact that we don't use them a lot means they're not at the tip of my tongue, but I do know there are folks who put together native seed mixes. It'd be something I'd have to look up to give you the who of it. But I was actually just on a big wetland mitigation bank site where they used a seed drilling machine. Oh, Go Natives, yeah, that's a good one, although I don't know if they do seed mixes, but so I know they're out there, and sometimes they may have to be collected on contract if you really have a large site where you need a particular seed mix, but it can be done.
Thanks. Yeah, and so I also put in the chat that Go Natives Nursery usually has bare root and potted up 4-inch plants. And if you really wanted to get into it, you could actually plant one of those and seed. So that's one way.
We grow them at Oxbow too. So if you need another
cool.
small nursery. And then of course, like the Washington Conservation District's nursery up in Bow, if you need huge volumes, or Fourth Corner is a great one for larger volume.
Yeah, and Erica wanted to mention for like the person interested in assisting in restoration efforts that Washington Conservation Corps, WCC, and the King County Conservation District, which is KCD, both like usually have opportunities. And then also we're part of the Green Seattle Partnership, and I'm pretty sure that they operate up there too. Yeah, okay, is there anything else? I'm just gonna really fast drop this link into the chat to remind you all that it's great if you fill that out.
I just had one more thing to give a shout out to. So part of our research team on this floating wetlands team, we applied for a grant to work with the Duwamish tribe on their Ridge to River restoration project. So I believe there might be opportunities there. I know we're trying to plan some bio blitzes in this coming spring season, but it's still kind of nebulous. So again, yeah, if you are interested in that, yeah, feel free to email me, same email in the chat.
Yes, great resource to mention. If there's no more questions, I will, this meeting was recorded, so I will upload it to YouTube in the next couple days, which usually just takes longer than you'd think it would. And then I'll send it out in an email to all of you with the link to the post-event survey. And then if it's okay with Matt and James, I'll include their contact information in the email also for any other questions that you guys may have. Yeah, if there's any more questions, like please feel free to put them in the chat, and I'm just gonna start closing out. Thank you everyone for coming to this wetland workshop event. If you haven't been to our wetlands in Del Ridge, check it out. It's a little bit weedy because our restoration events are much smaller, but we'll keep hosting events next year. And so yeah, stay up to date with our newsletter or on Facebook or any of our other places. Yeah, so thank you everyone. Thank you, Matt. Thank you, James.
Thanks for having us. Thanks for hosting the meeting, Bree.
Yeah, thank you so much. It's a great series of talks.
Thanks, and I'll follow up with you two in particular with an email too.
Have a good weekend, everybody.
You too. Bye, everybody. Happy holidays.